This is what's new in OpenBridge 2024. This is a quick overview of the new features being released. If you want further details, there's more videos included in this playlist. The technology stack that we use to develop OpenBridge, shown here, is based on MicroStation Power Platform version 24 and CM Platform version 24 as well. Let's start. We have included the option to generate deck contours. And before, to generate deck contours, it was quite difficult as it requires a learning curve to maybe export points and build a terrain model. Now we do it automatically. However, to generate these contours, you need to activate a config variable into the configuration file. As you can see at the bottom, OBM generate top surface model equal to 1. This variable is already there. You have to uncomment that. The deck surface is created as a terrain model. The controlling level symbology and spacing of the contours is done through an element template that is already included in our basic workspace. Another feature is the controlling deck elevation. Before, the controlling deck was used to place the beams. So now, as users may want to model, for example, the wearing surface and then the actual deck, so then there was no option to decide which one is the controlling one in order to place the beams and calculate the hunch. So now they will be able to do it. So for that feature, OpenBridge automatically picks the lowest elevation of the deck, and from that it will use that as a reference to place the beams. Approach slabs now can also take the super elevation DGN coming from open roads. Before it was only the deck. Now we got the option to apply it to the approach slabs as well. Not only just to define a super elevation table as we used to have in OBM, but the option to use the super elevation.dgn file as a reference as it may be generated in open roads. Some enhancements as well on the sleeper slab placement. There was a refinement, as you can see on the before picture. The library on the sleeper cell was having that straight, but now as the approach slab connects to the sleeper slab, we automatically adjust and accommodate that edge to the incoming approach slab following the roadway profile. We have also added the steel beam schematic generation drawing. So in here, you will have your create your bridge, and we will, as created in the reports, we will create a new 2D model in which you will have an elevation view, a schematic elevation view with a distortion for the span and beam that you select, and it will show the location of your cross frames, splices. For the beam layout, now we added the option to specify the beam spacing based on the chord, on the short chord option. So now this short chord is computed span by span. Before, the long chord will be just the whole extent of the curve along the bridge, but now we just segment that curve across the spans. So as you can see, the short chord is measured span by span from the intersection from the center line of the pier and the bridge alignment. And that's another option as a spacing reference on the beam layout definition. Beam flange decorators. So for that, on the beam layout, we usually place the center line of the beams, concrete or steel, but now we're placing as a decorator as well, in some level symbology, the beam outline, meaning the width of the concrete girder or the different widths that your top flanges on your steel girders may have. Right? So these apply for any type of concrete girder as well for the steel built up or rolled beams. On the beam layout, we got the option, as it shows in the attached video on the playlist, that you can rename the beam group. We used to have beam group 1, beam group 2. Now, after that placement, you can redefine the name of your beam groups as well as going to be reflected on the reports that you generate. Another option added here is what we call the concrete beam dabs and notches. So during the beam definition, after you place the beams on the advanced option, you will be able to generate cuts at the bottom or top of the beams, either saying by distances or slopes, in which we call dappled ends and notches. Of course, the elevations quantities being reported will be accurate because they are reading the model on the cuts that you just have performed. So they could be applied at the top and the bottom of the beam. For the inverted T's geometries here on the cap, you got options through the dialog box in your peer library to control how the inverted T it's straight or following the roadway profile, as well as controlling the offsets and depth of each side of the ledge. Adding prefixes when you create bearings, so you can classify them, and then of course they will be reflected in your reports, and you can rename them even after the fact. So as before, they were just labeled bearing 1, bearing 2. Now you can apply your own naming convention to do that. For bearing rotations, as you can have the option to rotate the bearings. Before, the bearings were not rotated with the beam. Now they automatically rotate. So it's applied when the bearing is the only component. If you got a ground pad or no bearing seat below, it doesn't apply. Also, bearing trimming. So you got a maybe heavily skewed cap and the bearing is square, so there could be elements of that bearing that are outside the cap. So we got the option to clip the beam seats to match the cap width that you're getting. And on bearing reports, now we have a new pay unit option that is by area. So now the top surface area, it's reported. On cheek walls, we added the option to cheek wall decorators. So as you place a cheek wall, that location of the cheek wall is also reflected as a decorator option, which is on level symbology that you can define, right? So it's done as a decorators. The cheek walls is just the name where we apply, but also people know it as shear keys, right? And we just create a new OBM level to define that. Some more cheek wall geometry options on how to represent the top of the cheek wall, maybe just straight or following the roadway profile, as well as the dimensions and heights of that cheek wall. So they could be just by default, they are slope, right? But you can change that through the peer library. Also, you can specify your own name for the cheek walls, so you can adjust it right in the peer library definition. And that just could be applied when you're placing it. For step caps, there is an option through a config variable until this time to specify the bearing seat width for your caps. You know, certain agencies define that with a standard instead of the half width cap dimension that we do automatically. Peak up elevations are also reported, so especially useful when you have a crowned deck. So we report the edges of the cap, as well as what we call the RL line or the reference line. That is the elevation at the intersection of the alignment with the pier center line. Now, automatically, the abutment back wall follows the slope of the profile. We used to have it straight, and the only way to do it was modify it manually, but now you can adjust it automatically following the roadway profile. Option to have a corbel and horizontal offset on the back wall. So that option is also defined through your pier library definition. Options for piles. Now we support the square encased pile. On the windward reports, we report more on the geometry elements as elevation and dimensions. Right? So we provide all that information, plus the cap, footing, and individual piles information is included if you have it in your windwall. Minor addition here, when you have concrete diaphragm for steel girders, now we allow the option to have a negative offset. For the excavation quantities, or once you perform excavation, we have included the option with its own level to display the excavation outline as a decorator. Fill splices, we have the option to specify now staggered bolts along the fill splice, as well as the direction on how this bolt is being presented in the 3D model. A lot of enhancements on parametric cells. You place the parametric cell, and we will give you the quantities of each one of the elements that you have previously tagged on the parametric cell, as well as elevations are reported, the geometry elements, and also item types that are generated automatically, taking into account the information that you have used or the variables that you have used to create that parametric cells. We are adding the option, a new workspace, as a lot of agencies are starting to implement the international food definition. So we have added the options to a new workspace that includes that international food. The standard one, as we still use, is the survey food. We just rename it. So now it's the imperial food, it's the international imperial survey food, the one that we're using, it's called the metric standards. This is a comprehensive change, not only on the actual seed file itself, but on the drawing seeds and the other definitions that are affected by this new footing dimension. We also now show the profiles that are being used on the bridge. We usually reported just the alignment name, but now what is the active profile that is controlling the bridge. Taking advantage of the civil platform, we are adding more commands into what we can do with OpenBridge. So adding these points and complex geometry commands in OpenBridge. A new workflow has been added as well for OpenGround. So there is an OpenGround integration now with a geotechnical extension workflow that has been added. And we also added as well a new tab in which we have grouped the most common used tools to do drawing production. So there is annotation, there is section callouts there. As you know, you can customize it as your own preferences, but we think that this is more or less what you need to do, or what you need to collect to within the same tab and the same workflow to easily generate or annotate your plan sheets. As a summary, we have more than 40 enhancements, major and minor, on what we have done in this release with OpenBridge. As I said, you got more detailed videos on this playlist, which you can explore all the options that we have mentioned before. On the analytical side as well, in Leap, very specific enhancements on to add on the interface for horizontal shear design. More information into that and details on the release notes of each individual application, Leap Concrete or Leap Steel. Automatically generate limit states, for example, for the wing loads. And also the minimum and maximum reinforcement check for the substructure design. This is for both Leap Concrete and Leap Steel. For Leap Steel, now we support the concrete diaphragms that you define in OBM, now in steel bridges. Some deflection check details at each point of interest. Field splice design summary report. And design check on the tension flanges too. More options too. Fatigue design checks at the cross frames. We can visualize now the influence lines. Connection reactions at the end of the cross frame. An option to include the stiffeners in the finite element analysis in the analytical model. For RM, we have multiple enhancements as well. First, we allow the transfer of tapered ring cross-sections coming from OBM to RM. We can also generate the internal pre-stressing tendon layouts when transferring from OBM to RM. As well, the RM tendon materials are included when sending the model from OBM to RM. We can also choose the sequential numbering for the deck definition when we transfer from the physical model to the analytical model in RM. Enhancements on a flare composite steel deck transfer. We have a new schedule action, the model shell thick end. With this action, the user can change the stiffness properties of the shell elements during the running and choose between one membrane and plate behaviors. We can also extract tendon data from the OpenBridge model. And tendon forces are now accessible on the TCL file via that command. For any more information, please go to the release notes of every product. And thank you.